my name is Jim Burnham. I am an engineer turned teacher. So I spent most of my career, 25 plus years. I worked at Amdahl, and then most of my career at a company called Xilinx. But then 8 years ago, became a mechatronics teacher here at Silicon Valley Career Technical Education Center in San Jose, in Silicon Valley. And my class is mechatronics, so mechanical engineering, electrical engineering, mash those together, fire-breathing robots. But one of the things I want to do is add a lot more material. I already teach, semiconductors. We teach about gates, AND gates, OR gates, and, digital logic and transistors, things like that. But I really want to formalize this more as a pathway into the silicon manufacturing, silicon design environments. And so one of the things that I am a huge supporter of is Creative Commons, open source. And so AKA I am Steam Clown. Everything I do, everything I put together for teachers is available in an environment that they can do stuff. And so one of the things I want to be able to do is replicate and create this material so that other teachers can actually use it. And so one of the things that I've been doing is working with Precision. Enduran and I have been working on a number of projects which really help drive folks into the silicon design, silicon manufacturing environment. And one of those projects is OpenROAD. So OpenROAD is this initiative. We've got a website here and a place where we can put all of the material, all the classes, all of the stuff that other teachers can actually use. And we're doing three paths, three focus areas. One is foundational path, one is partial path, and then one is the full path with OpenROAD. The foundational path is really focused on what is a transistor. We have a section here that is the introduction to semiconductors, and here I've been actually working with a number of groups. Ignited, they've created about 6 or so plus lessons, 8 lessons focused on the silicon semiconductor industry and what it is and what's interesting about it and why students should be interested. And they're big on workforce development. So Foothill College, Semi, Ignited, and the Krauss Center for Innovation, we've all been kind of working on these. And I'm actually testing them and trying them out and creating some more high school focused kinds of things. And then of course we're doing more things in this foundational path. It's what is a transistor and what is an AND gate, OR gate, and all that kind of stuff. The partial path is really focused on tiny tape out, and this is where a student can actually take a design, do some Verilog, and run it through their process and actually submit and get it on a shuttle, and 6 months later, so get silicon back and actually play with it. And what I found is the students aren't super excited about saying, hey, you've just ran a Verilog script and now you have a GDSII file. Yay! No, they want to actually have silicon in their hands. And then, of course, this full path is really where we're focused on the open source tools that allow you to take a design using tools in industry and be able to go from Verilog to GDSII. And this is really the place where Precision and I have been really focused. And so, please consider us. I actually have just received a die bonder and hopefully get that up and running. So we do have some resources to do some really fun, cool things. Anyway, thank you very much.